What's up, everybody? MattyNum3ers here. So tonight, episode 3, I'm going to switch it up a little bit, cover the NFL playoffs in episodes 1 and 2. We're going to talk about fantasy baseball, one of the ever-evolving pieces of analytics to take into consideration when it comes to full-season fantasy baseball. It is a little-known analytical concept called SaberMetrics. This is the mathematical and statistical analysis of baseball records. To understand the field of SaberMetrics, one first should be familiar with the game of baseball, also known as America's national pastime. Baseball, as many of you know, began in the U.S. in the mid-1800s. Professional ball started near the end of the 18th century. National League founded in 1876. American League founded in 1900. And baseball is played between two teams consisting of 9 players. 9 players are a pitcher, a catcher, first baseman, second baseman, shortstop, third baseman, left center, right fielder. A game of baseball consists of 9 innings, so on and so forth, right? We all get the basic concept of the game, but what most of us don't understand are how the basic statistics of the game come together and analyzed in what we like to call SaberMetrics. So with that said, one of the first things we want to cover are basic batting statistics, right? One notable aspect of the game of baseball is the wealth of numerical information that's recorded about the game. This is the effectiveness of batters and pitchers, and it's typically assessed by particular numerical measures. The usual measure of hitting effectiveness for a player is the batting average, which is computed by dividing the number of hits by the number of at-bats. The statistic given to the proportion of opportunities, better known as at-bats, in which the batter succeeds or gets a hit, in this case, single, double, triple, home run, anything along those lines. The batter with the highest batting average during a baseball season is called the best hitter that year. Batters are also evaluated in their ability to reach 1, 2, or 3, 4 bases in a single hit. We just covered that 2 seconds ago. The slugging average is computed by dividing the total number of bases, in short, total bases, by the total number of opportunities. This factors in walks as a single base. Keep that in mind. It weighs hits by the number of bases reached. The measure reflects the ability of a batter to hit a long ball for distance. The most valued hit in baseball is the home run, where a player advances 4 bases on 1 hit. The number of home runs is recorded for players, and the batter with the largest number of home runs in the season is given a special recognition. We all know this. This is pretty straightforward stuff. The basic pitching statistics, right? This is, a number of statistics that are used for the evaluation of pitchers. For a particular pitcher. Any single pitcher, doesn't matter who it is, doesn't matter how good he is. One counts the number of games in which he was declared the winner or loser and the number of runs allowed. Pitchers are usually rated in terms of the average number of earned runs allowed for a 9-inning game. Other statistics that are useful in understanding pitching ability are things like complete games, quality starts, wins, losses, a pitcher's whip, things along those lines. A pitcher records a strikeout when the batter fails to hit the ball in 3 attempts or gets 3 strikes, swinging in the zone, foul, whatever. As long as the foul's not a 3rd strike, he swings, he misses, it's a strikeout. A pitcher who can throw the ball very fast can record a high number of strikeouts. Randy Johnson, Nolan Ryan, so on and so forth. A pitcher who's considered wild or relatively inaccurate has a tendency to record a larger number of walks. Pretty straightforward stuff so far. Basic hitting, basic pitching. Let's get into a little bit more of the detail, right? So one of the better ways to measure hitting, or hitting ability in which runs are created, and this is one of the basic goals of SaberMetrics, is to find good measures of hitting and pitching performance. One of the architects of modern-day SaberMetrics is a gentleman by the name of Bill James. In 1982, he compared the batting records of 2 players, Johnny Pesky and Dick Stewart. Both these guys played in the 60s. Both these guys were animals. Pesky was a batter who hit for a high batting average. Stewart, in contrast, had a modest batting average but hit for a high number of home runs. Again, consistent league leaders always at the top of those specific statistics, so on and so forth, right? Who's the more valuable hitter? Bill James argues that the hitter should be evaluated by his ability to create runs for his team. For an empirical study of a large collection of team hitting data, he established the following formula. A run equals the division of hits plus walks times total bases over at-bats plus walks. It's a basic sort of division equation, right? We have to take the total hits and walks, throw that in parentheses, total number of total bases, throw that in parentheses, multiply the two together, divide by the total number of at-bats plus the total number of walks. This formula is going to reflect two very important aspects of scoring runs in baseball. Number of hits and walks of a team reflects the team's ability to get runners on base. Very positive factor here. The total number of bases of a team reflects the team's ability to move runners that are already on base. The runs created formula, as I talked about above, can be used at an individual level to compute the number of runs that a player creates for his team. So, for example, as Bill James notes, in 1942, Johnny Pesky had 620 at-bats, 205 hits, 42 walks, 258 total bases. Using the formula I've discussed above, created 96 runs for his team. Dick Stewart, on the other hand, had 532 at-bats in 1960 with 160 hits, 34 walks, 309 total bases, and 106 runs created. The conclusion is that Stewart in 1960 was a slightly better hitter than Pesky in 62, since he created a few more runs for his team based on the numbers that we know. So, first things first, right? We're talking about the measure of hitting ability and how important that is to determine the better hitter using SaberMetrics. These are all factors we want to take into consideration, right? When we're drafting a full season professional, full season batter during our drafts, which are spring training, mid-season, so on and so forth, we want to understand that there are multiple statistics in which we have to keep an eye on, and we really want to use this to determine who and where may be the better hitter. It's not always going to be the guy that hits the most home runs. Keep that in mind. So, moving on, let's talk about linear weights. As an alternative approach to evaluating batting performance, is based on a linear weights formula. What this means is the first person to assign run values to each event that could occur while a team is batting. It's sort of interesting, right? So by using the recorded data from baseball games and probability theory, a gentleman by the name of George Lindsay developed the following formula. Runs equal singles plus doubles plus triples plus home runs. Singles have an intrinsic run value of 0.41, doubles 0.82, triples 1.06, and home runs 1.42, where single, double, triple, home run are respectively the number of singles, doubles, triples, and home runs hit in a game. One notable aspect of this formula is the fact that it recognizes that a batter creates a run three ways. He walks, he hits a home run. That's how runs are theoretically created. Obviously, as we get to more modern day statistics like stolen bases, that has a probability to factor in as well, somewhat on the lower end of the scale. We'll get into that when we talk about advanced sabermetrics a little bit later in a couple episodes. Anyway, back to the basics of linear weights. So, there's a direct run potential when a batter gets a hit and gets on base. In addition, the batter advances runners that are already on base. Also, by not getting an out, the hitter allows a new batter a chance at getting a hit by a pitch, walk. This is what's coming into play here. And this reduces indirect run potential. One of the more sophisticated versions of linear weights formula was produced by Thorne and Palmer back in '93. This predicted the number of runs that were produced by an average baseball team based on all of the offensive events recorded during the game. Like James, the runs created formula, again, a little bit advanced linear mathematics here, can be used to evaluate a player's batting performance. Something we need to keep in the back of our head when we're, looking forward, looking for potential sleeper picks. Round 3, round 4, round 5, round 6. This is really important information, right? So the next piece of today's sort of basics, and this is going to be the third of 4, is going to be runs to wins. Although scoring runs is super important in baseball, obviously the most runs scored wins the game, the basic objective is for a team to score more runs than its opponent. To learn more about the relationship between runs scored and the number of wins, we need to look at the number of runs produced, the number of runs allowed, the number of wins, and the number of losses during a season for a large number of recent Major League games. Take this over the course of 2-3 seasons. Bill James noted that the ratio of a team's wins to losses was exactly, or approximately, or closely, or very closely, to equal to the square of the ratio of runs scored to the runs allowed. Essentially, what this is runs equal wins over wins plus losses, which equals runs squared over runs squared plus the opposition's runs squared. The relationship can be used to measure a batter's performance in terms of the number of wins he creates for his team. How many times did X batter hit the ball to win a game is what this essentially comes down to. And how many times can we forecast him to run the game based on advanced, equations of this specific formula looking out, over the course of the next subsequent series of at-bats, games, or seasons. The last piece of this that I want to cover is what we like to call a better measure of pitching ability. Sure, we can use the simple form of how many runs did a pitcher give up per 9 innings versus how many runs a pitcher gave up in a quality start. We know the definition of quality start, right? 6 innings pitched, 3 or less earned runs. The better measure of pitching ability in this case has to do with the standard pitching statistics, number of wins and the number of earned runs per game, better known as the ERA, are traditionally flawed. The number of wins of a pitcher can just reflect the fact that he pitches for a good offensive run-scoring team. What ERA doesn't measure is the rate of the pitcher's efficiency. Versus the actual benefit of the pitcher over an entire season. Essentially, let's say I pitch 2 quality starts. I pitch 6 innings, give up only 2 runs in those first 6 innings. But I still lose both those games. Those losses don't tell the full story. They tell you that I had a quality start, but they also tell you that my bullpen screwed up pretty hard. So Thorne and Palmer concluded in 1993 that the pitching runs formula, which is pitching runs equal innings pitched times league era over 9 minus earned run. So pitching runs equals innings pitched times league ERA divided by 9 minus the number of earned runs in play. Basically, the factor of league ERA over 9 measures the average runs allowed per inning for all the teams in the league. The value of this is multiplied by the number of innings pitched by that pitcher. This product represents the number of runs that pitcher would allow over the season if he was an average pitcher. Essentially what this does is the league ERA divided by 9, since it measures the average runs allowed per inning for all the teams in the league, this is going to show up on any quadrant, any graph with 4 quadrants as the center circle, 0, 0, essentially, right? There's going to be 15 above, 15 below, so on and so forth. Lastly, one subtracts the actual earned runs the pitcher allowed for the season. If the pitching runs is larger than 0, then this pitcher is better than average. The new measure appears to be useful in measuring the efficiency and durability of a pitcher. So with that said, covering things like, the better measure of hitting ability to runs created, linear weights, runs to wins, and of course the better measure of pitching ability are all things we want to take into consideration during, our basic overview of SaberMetrics. What I'm going to do throughout the course of the season, and as we get closer to, the late February, early March drafts, is going to go into some of these. One of the things you want to keep in mind is that I'm going to have my own version of this. There's going to be 42,000 other versions of SaberMetrics, twists, so on and so forth. What I'm not going to do is I'm not going to give you specifics. Reason being is this has taken a very, very long time to measure up, to use, to apply correctly. This has taken trial and error. This has taken seasons upon seasons of application. It's not for everybody, but what I am going to tell you that the information that I'm providing to you is going to be the stepping stone for you to do a little bit more research, to get a little more clarity, to apply this in your own series of formula, and then go from there. Like I said, SaberMetrics are the way that modern day pro fantasy baseball players who take part in full season, high reward events apply to the way they sit down and strategize draft formulas They sit down and determine who's a better hitter and who's not a better hitter. They determine whether they're going to draft the home run hitter or the guy that hits for consistency over the home run hitter. It all comes down to analytics. At the end of the day, it comes down to analytics and just a little bit of luck. So with that said, Matty Numbers out. Have a good night, everybody. Hope you enjoy it.